Okay, so first of all, this chapter, chapter 5, is probably one of the more theoretical chapters where you're really having to do a lot of like understanding what's going on with the atom. But we aren't covering the whole chapter. And in fact, we have a summary page. So I want to show you guys at the end, if you go to page 8, is that last notes. I passed this out, or a page that looks like this, last time. And you'll notice that I've got all these pictures on here, kind of some helpful hints for everything. This is basically like a great summary page. And now that you have open notes, you are super duper lucky. I want to point out something. There's these letters here, these SP kind of letters right here. See those? They're like huge in this chapter. The great thing about it is that if you know the bonding going on, so if you know that it's linear, you can already go ahead and say that that's SP. And if you know something's trigonal planar, you can say, oh, that's sp2. If you know it's tetrahedral, you can say, oh, that's sp3. If you know it's trigonal bipyramidal, that's sp3d. And if it's octahedral, it's sp3d2. That applies for all of these other guys in this category. They all end up with that same set of numbers. And those numbers are called hybridization. And it's something that you get asked a lot of questions about. So they'll say, oh, we have this molecule right here. Can you tell me what's its hybridization? And you just say, oh, it's sp. See how there's an easy kind of a shortcut to this? There's two more things to note, is that in this category, and we'll mention this one, kind of like the max that you can have is sp3. This is what a lot of things are. That's that tetrahedral situation. But in this category, you see how this is sp and how it's like it's missing two p's? So you have two extra p orbitals that aren't involved in the bonding. So I meant to write two unhybridized p orbitals right here. So change that word to unhybridized. And then in the second category, one, again, unhybridized p orbital. And what you want to know about this is that those p's and those p orbitals can do their own special kind of p overlap. And these are the orbitals that are going to be able to make the double bond part of a double bond or a triple. And this should say two double bonds. Like this page is your resource, huge resource for like everything you need. All right, so I'm going to go back to that first page. We're going to talk about bonds.